Hi everyone, in this tutorial I am going to discuss a very interesting problem, next greater element 2. So basically we have to find the next greater element in a circular array. So I have already explained its easier version, which is find next greater element in an array, and the link of that video tutorial is present in the description box. I highly recommend to solve its easier version first before solving this problem. Now let's discuss this problem. And as usual, first we understand the problem statement, then we discuss multiple approaches to solve this problem, and finally we will write its Java code. So let's start with the problem statement first. In this problem, we have given a circular integer array. And what is circular array? We will discuss this part once I complete the problem statement. So in this circular array, we have to return the next greater number for every element of an array. And the next greater number of a number x is the first greater number to its traversing order next in the array. So basically, when we traverse an array from left to right, the next greater number of a number x is the first greater number to its right, which means, so basically it's a circular array, so we can traverse an array circularly to find its next greater number, and if it does not exist, then we have to return -1, else we have to return its next greater number. And what is circular array? So in circular array, after the last element of an array, so in this array, the last element is 1. So after the last element of an array, the pointer again start from this 0th element. So you can imagine this circular array in this fashion. So 1 to 1, and then again this array is repeated 1 to 1. So after the last element, again we go back to 0th, then first, then second. So basically this is the circular array. Now let's understand this problem through multiple examples. So in the first example, we have given this array which only consists of 3 elements, 1 to 1. So by taking the first element 1, its next greater element is 2. So at 0th index, 2 is the next greater element of 1. For 2, if we search, so if we find its next greater element, let's say now when we compare with 1, 1 is not greater, and after that we compare with 1, again it's not greater with 2, so it is equal. With 1, again it's not greater, so we return -1. For 1, so this is the last element of an array, but the array is circular. So again we compare with 1, then we compare with 2. So 2 is the next greater element of 1. So this is the output, 2 -1, 2. Now let's take the second example. For second example, when we start with 2, so you can see 2 is also greater, 3 is also greater, 4 is also greater than 1, but we have to find the first greater element, and the first greater element to its right. So 2 is the first greater element, so 2, we write 2. For 2 it is 3, for 3 it is 4, and now for 4 we compare with 3, then 1 2 3 4, so we find none, so let's write -1. For 3, so it is the last element of an array, but the array is circular, so again we compare with 1, then 2, then 3, then 4. We found the next greater element, which is 4. So this is the output, and this is the problem statement. Now let's discuss multiple approaches to solve this problem. Let's start with the simplest solution, and then we will optimize our solution and solve this problem in linear time. So the simplest solution is to create a new array whose size is double than the original array. Now imagine we have given this array as an input 1 to 1. So let's create a new array whose size is double than this array. So the size of this array is 3. So let's create a new array whose size is 6. So let's count the indexes 1 2 3 4 5 6, and now let's copy this array twice, 1 2 1 2 1. Then for each element of the original array, what we can do, we can find its next greater element. So let's take 1, and for 1, when we find, and also let's declare one output array. So basically the size of the output array is same as the input array, and let's take this number 1 and check its next greater element. So we found its next greater element, and so let's put 2 at 0th index. Now for 2, let's check. For 2, we search in this array 1 1 2 1. So no greater element found, we found which so no element we found which is greater than 2, so we put -1 for 1. So let's start. For 1, let's start checking uh, in rest of the elements. So for 1 it is equal. For 2, now 2 is the next greater element of 1, so we put 2 here. And now we have found the next greater element. For every element of an array, we return this result. So you can see this code. So here I have declared one variable n, in which I have assigned its length. Then I have declared one new array whose size is double than the original array, and one output array. Basically we have to return the output in, we have to return the result in array format. So its size is similar to the input array. Then I have copied this array twice. So this is the helper method. So basically it takes the source array, the destination array, and the source start index and destination start index. So basically you don't have to implement this method. I'm just explaining so that we can start with the simplest approach, and then we can visualize how, if we have to start this brute force approach, how we can do, and then how we can optimize this approach and solve this problem optimally. So here I am copying. So basically first we start with 0th index, and also from destination 0th index. So let me draw this so that you can visualize it. So this is the size of the destination array. So basically it is double the size of the input array. And when both the both start source, so this is the source start index and this is the destination start index, both will start from 0. So I'll take this and I copy 1 to 1. Then again the source will start again from 0, but destination will start from n. So again when we do, I'll copy it 1 to 1. Now we have this array, new array, in which the original array copied twice. So basically in circular array also you can imagine it is 1 to 1. So after the last element we again point to the first, and then second, then third, something. So we can copy this. Basically we have copied this array twice, and then basically we have to find the next greater element for these 3 elements only. So we run the loop from 0 to n, so the size of the original array, and initialize with -1, so that if no element which is basically greater than this element, so we set its default value -1. Else if any element is found which is greater than this element, we can put that element at this index, and the inner loop will start from I plus 1. So for, if we have to find the greater element for this element, the inner loop will start from this index, and at any point if we found the next greater element, we just put the next greater element and break the loop. Else so basically else if no new element is found, we already assigned its default value, which is -1. And after the complete iteration, after so let's say its size is 3, after running the loop for 0 1 2, this loop will break and we return its output. So this is the easiest approach. Now let's talk about its time and space complexity. So basically its space complexity is big O of n, so we are using the extra space, and its time complexity is big of n square. We are using 2 for loops. Now let's see how we can improve this solution. In our previous approach, we have declared an additional array and copied the array twice. So basically, we don't have to, use the additional array. We can solve this problem without using additional array. And how we can do it? So basically, let's say if this array is circular, and in this array we have 3 elements. So let's say if I go to third index, it will go to the uh, it will point to 0th index. If I go to 4th index, it will point to 1st, and if I go to 5th index, it will go to 2nd. So what we can do is we can take the size of this array. So basically the size is 3, and for every element we can do the modulo operation. So 0 modulo 3, so the remainder is 0, so 0th index. 1 modulo 3, so the remainder is again 1. Now let's see if we do 3 modulo 3, so basically the remainder is 0, and if we do 4 modulo 3, the remainder is 1. So what we can do is, here I have we can run 2 for loops. So the outer loop will run from 0 to less than the original array length, which is input array length, and for inner loop we can run the loop from I plus 1 to which is less than the twice the size of the original array. And for every iteration we can do this modulo operations, so that we don't have to use the additional array, and also this clever technique saves us the extra space. So let's imagine this operation. So this is very straightforward. I have assigned the length of an array in this variable. I have declared one output output array whose size is equal to the input array, and then in output array I fill its initial value -1. Then I run this loop, and for this basically what I'm doing here is, so let's say the first element is 1, and in output array, so basically I put -1, -1, and -1. So for 1 I run the loop with this inner loop will start from I plus 1. So we compare, is the element which is present. So basically j modulo n, so the value of j is 1, and when we do the modulo with 3, so it is 1. So we are comparing with this element, and if it is greater, so at this index we put the value and we break the loop. We have found the next greater element for this element. Now let's take 2. For 2 we start the inner loop from this point and we compare with this element. No, it is not greater. So then we increment the value of j, and the value of j after first iteration is 3. And when we do 3 modulo 3, so we again come back at this index and again we compare. So no, it is not greater. Again we compare with this, it is not greater, it is not greater. So -1 remain as it is. And then so in the last iteration, when the value of I is 1, so j will start from this point. So the value of j, so when the value of I is 2, the value of j will be 3, and 3 will, so when we do 3 modulo 3, it is basically 0. So we compare with 1. So no, it is not greater. 2, yes, it is greater. So we put 2 here. So we put the 2, and then we break the loop, and after that we return its output. So we can, we can skip this process. We don't have to do array fill as well. Instead what you can do is you can do the output and the I index and -1 here. If you don't want to use this extra, I mean, iteration to fill this array with -1, you can do here, you can initialize a -1 at this point. Now let's talk about its time and space complexity. So basically its space complexity is big O of 1. We are not using any extra space. Don't count this as an extra space, as we have to declare this array just to return the output. I mean, it is the function signature. I mean, it is the function requirement to return the output as an array. And then its time complexity is big O of n square, as we are using 2 for loops. Now let's optimize further and let's solve this problem in linear time. To solve this problem in linear time, here I am using stack data structure. So why I am using stack data structure and how stack data structure help us to solve this problem in linear time, you will understand them shortly. So first, let's go back to the problem statement. So in this problem, what we have to do, we have to find next greater element for every element of an array. And what is next greater element? So next greater element is first greater element to its right. For example, for 1 it is 2, for 2 it is none, and for 1 again, when we do the when we traverse this array circularly, it is 2. So basically in a stack, what we do is, so initially this stack is empty. So let me write its indexes as well. So stack is empty. So I put the index of the first element. So I put 0. Next we move the pointer, and the next element which is present at first index is 2. So what we do is we always compare the next element to the element which is present at this index. So basically this element is present at the top of the stack, and we store only the indexes in a stack. So we compare the element which is present at 0th index and the element which is present at the first index. So is this element is greater than the element present at 0th index? If it is, so what we do is we pop this element, we pop this index from the stack, and for this index we know the next greater element is 2. So at this index we put this value, and now the stack is empty, so we put the current index in a stack. Now at current in so at the top of the stack points to so at the top of the stack we have this value 1. So next, when we take this element, the element which is present at the second index, again we compare with this value. So the value which is present at first index, so at first index the value is 2, and at this index the value is 1. So the current value is smaller. So definitely 1 is not the next greater element of 2. So we simply put this index 2, and now the top of the stack represent this value. So at top of the stack, so when we do stack dot peak, so we get 2. So at top this value is present. So we can traverse this array circularly. So this is a circular array. So next we move to this index, and the element present at this index is 1, and so we take this element and we compare the element present at second index. Again it is equal. So we move to this index and we compare 2 with the element present at this index. So this time it is greater. So we pop this index from a stack and we put this 2 here. For this value 2 is the next greater element. And now when we compare this with the element present at first index, so again both are equal. So let's move to the next index, and now when we do stack dot peak, so the value present at the top of the stack is 1 now because 2 is popped out. So and the value present at this index is 2. So again when we compare with 1, it is not so it is smaller. So after that we came out of this loop and we have not found any next greater element for this element, so we return this output. So that's how the stack data structure help us to solve this problem in linear time. Now let's see the code. So this line is straightforward. Here I'm assigning the length of the input array, and the so when we declare the output array, its length is same to the input array. And then here I have declared a stack which holds the value of integer type, and initially I put the initial value -1 to all the indexes of this output array. Then I run this loop from 0 to 5th index. So basically the size of the input array is 3. So when we multiply with 2, it is 6. So this will run from 0 to 5. And why we are running from 0 to 5, I have already explained a couple of times, because it's a circular array. And so we do this clever technique. Basically we take the current index and we divide with the input size of an array. So when we do so basically we do the modulo operation. For 1 modulo 3, it represents the first index. For 3 modulo 3, it represents the 0th index, because after the second index again we go back to 0, then 1 and 2. So this condition, so this is the condition I have explained here. So basically if a stack is not empty and the element which is present at current index is greater than the element which is present at the top of the index. Basically in stack we keep the indexes. So if the element which is present at current index is greater than the element which is present at the top of the index, so in output array we take pop the index of a stack. So basically pop the top element, and there we assign. So basically for that index we found the next greater element, so we put this value, and we keep repeating this process until this condition is true. For example, let's suppose if the array is 1 1 2. So initially when we put in a stack, it is 0, then 1. So here I am talking about the indexes. So 0th index 1, but when 2 comes, so basically for this element also this is the next greater element, and for this element also this is the next greater element. So to handle such scenario we have to use this while loop, and we have to find the next greater element for these 3 elements only. So this condition ensures that we push only these 3 elements, I mean the original size of the array. So after that, once the iteration is completed, we return the output, and the output is 2 minus 1 and 2. Now let's talk about its time and space complexity. So its time complexity is big O of n. We are doing this in a single iteration, and its space complexity is big O of 1. We are using additional space. We are using additional data structure stack. So that's it for this video tutorial. In this video tutorial, I have explained 3 approaches to solve this problem. We have started with a very simplest approach, and then we have optimized our solution. And apart from that, if you know any other approach to solve this problem, please let us know through your comments, and please like and share this video. And if you are new to this channel, please subscribe this channel. Thanks for watching this video. Thank you.